Hello everyone. So in this video we'll discuss about analog to digital converter. So analog to digital converter is the one which converts the analog voltage to the digital output. Okay. So one of the best method they used for analog to digital converter is successive approximation analog to digital converter. So it consists of 8-bit SSR, that is successive approximation register, so which has a clock input and the serial data input from the comparator. So output is the serial data output, the start signal and the comparison complete signal which is connected. So these are the latch enable which is connected to a 8-bit latch which provides the digital data output. Okay, so the output of the SAR is given to the 8-bit DAC, so that is digital to analog converter. So this signal is compared with the comparator, and so on the comparator output is given to the serial data output. So we'll see how does it work. So the heart of the circuit is the 8-bit successive approximation register whose output is applied to the 8-bit digital to analog converter. So this is also 8-bit and this is also 8-bit DAC. So it consists of 8-bit registers. So each register will store 1 bit data. Okay, the analog output, so the data from the 8-bit SAR is given to the 8-bit DAC, that is digital to analog converter. So this data is converted into analog signal from the 8-bit DAC. Okay, so now the output of the DAC is analog signal. So the input is applied to the comparator, so one of the terminal. So here is non-inverting terminal and the output of the DAC is applied to the inverting terminal. So now this becomes the reference voltage. So depending on the reference voltage, so output will be either high or low, and depending on this output is given to 8-bit SSR where it stores the data. Okay, now so the SAR adjusts its digital output until it is equivalent to the analog input Vin. So this combination, so 8-bit combination will be keep testing. So this is trial and error method. Okay, so the 8-bit latch holds the resultant digital data output. Okay, so we'll see the working. Okay, so at the start of the conversion cycle, that is converting of analog signal to digital signal, SAR reset, that is all the registers of SAR will hold 0 0 0 0 by holding the start signal high. So the start signal will be high. So upon the next clock pulse from low to high, that is from low to high, so the most significant output bit Q7 of the SAR is set, that is Q7 will be set 1 0 0 0 0 0. So now this input is given to the DAC, that is 1 0 0 0 0 0 will given to the DAC. So the DAC output now will be corresponding analog signal. So this analog signal is compared with the Vin which acts as a reference voltage. Now that is if DAC signal is greater than Vin, that is if Vin is less than the reference voltage is less than the DAC output, so MSB will clear, so Q7 will be clear. On the other hand, that if Vin is greater than the analog output, that is the input voltage is greater than the output voltage, the SAR will keep this Q7 value as high. So that will be stored in this latch, 8-bit latch. So now the first digital data output which is corresponding to this analog input is 1. Okay, so I'll repeat again. So upon receiving, so now the 8-bit SSR will be reset. Upon the next clock cycle, so the Q7 will become high. So this is trial and error. So 1 0 0 0 will be there. So this input will be given to the 8-bit DAC, so which converts this digital data into analog input. So now the two inputs to the comparator is the analog input. Okay, so if this input, so if this output, DAC output is greater than Vin, Okay, so in other words, if V in is less than DAC output, so Q7 will reset. That is not a valid data. Okay, suppose if V in is greater than this DAC output, then SAR will keep this Q7 values high. So 1 is the valid data. So that will be stored in the latch. So next, in the next data, so otherwise the Q7 will be stored as low. Okay, now for the next cycle, next clock pulse, Q6 is made high. Okay, that is set. Now the data is 1 0 0 0 0 0 0 0. So now this data is converted into analog output. So again it is compared. If V in is less than this output, so it is set. Q6 bit is set and stored here. If V in is greater than this, the same output is given to the SAR and this will be stored in the latch. Okay, so this process is continued until SAR tries all the bits, till all the bits is tried. So all the combination has been tried. So as soon as LSB Q0 is tried, the SAR forces the conversion complete signal to indicate high signal height, that the parallel output lines contain a valid data. Okay, so conversion complete cycle will go high. So as soon as Q0 bit is tested, test of Q0 bit is completed, conversion complete signal will go high. So indicating that parallel output lines contains the valid data. So this line, the parallel lines will contains the output data. Okay, so this CC signal will enable the latch now. So see when CC signal will go high, this will enable the latch and the digital data appears at the output of the latch. Okay, so the advantages of successive approximation of analog to digital converter is its high speed and excellent resolution. Thank you.